Hello, how are you? I hope all of you are fine. So we came for the another lab. It is the lab 11. So in this lab, it is a UV visible spectroscopic analysis plus back titration. Okay. So in your book, it is written only the UV visible spectroscopy, but here we will also learn the back titration as well. So you know what is the back titration. In the back titration, we normally add known concentration of some excess amount of the known concentration, then that excess amount we can find out with the help of the other known concentration of the substance. So UV visible spectroscopy and back titration. Here in this lab, actually this is one of my favorite lab, because as I mentioned at the beginning of our semester, that so in the analytical chemistry we normally learn different techniques to find out the concentration, the qualitative and quantitatively the the qualitative and quantitative analysis of any substance. So this is a very good demonstration to find out the quantitative amount of the of a complex compound. So this one actually contains three things. One is nickel, another is ammonium, and another is chlorine. So what we'll do, we will give you a salt, a complex salt, okay, of nickel ammonium chloride. Okay, nickel ammonium chloride. So in this nickel ammonium chloride, we will not give you what is the empirical formula. Nickel, this is X, this is Y, this is Z. You have to find out with the help of the UV visible spectroscopy and back titration. You have to find out the what is X, what is Y, and what is Z. Okay. So UV visible spectroscopy. So what is X, what is Y, and Z? So if you take a look at this, you will see that this is nickel, this is ammonia, and this is chlorine or chloride, whatever. After that it will become chloride. So this one you actually don't know how to find out the amount of the nickel. But if you take a look at this ammonium, you know that that is a base. So if it is a base, we can find out the amount of the base by the help of the acid-base titration. We know that, right? We learned it. And what is the how can we find out the chlorine? For today's lab, we will not actually find out the amount of the chlorine. Okay, we will find out the amount of the chlorine in some other way. So, but if you need it, you can find out the chlorine with the help of the silver chloride. The silver chloride, if you add the silver nitrate, it will produce the silver chloride precipitated. So anyway, for today's lab, we will find out the amount of the nickel. You know the amount, how to get the amount of the ammonium, but you don't know what is the way to get the nickel. So nickel is the so this nickel is a transition element. Okay, what is the transition element? Which has the empty d orbital. Okay, in their structure, when it has the empty d orbital, it is a transition element. So you know that transition element shows variable oxidation state, and as well as transition element give the colorful compound. Which are the colorful compound? We can find out those colorful compound, the amount of those colorful compound with the help of the UV visible spectroscopy. Okay, so UV visible spectroscopy for the nickel, it has a specific lambda, like it has a specific wavelength at which its absorption is the maximum. Okay, it's called the lambda max. At a specific wavelength, the nickels give a maximum absorption. Okay, and for the nickel it is 395.8. okay, for the nickel it is 390. If instead of nickel, if you will use the copper, or if you will use the iron, it will be different for the different. And but this wavelength is specific for the specific metal. Okay, so for the nickel it is 395.8. okay, so let's see how actually UV visible spectroscopy works. So you know what is the visible spectroscopy. Visible is 400 to 800 nanometer, right? But UV, that means some other range. So this is 400 to 800 nanometer, the visible range. Okay, light. So UV, since UV also included, so we are actually UV start from the 200. So we will actually use from 200 to 800 nanometer of the light, and we will use this as a light source. So we will use a light source. Okay, this is actually a small machine. So how the machine work, I'm just trying to explain you a little bit. I think Dr. Zhao also already explained you in the class. Anyway, so this will be a light source. So if your light source, the light comes from there, and then there will be a slit. In this slit, it only let you go the 200 to 800. Okay, since we are analyzing among that range, and you will have some sample here. We call it the cuvette. Okay, cuvette is look like this cuvette. It's a like that. Okay, you know. So where all are actually 1 centimeter, the weight and the diameter. Anyway, so except the length, this is 1 centimeter, this is 1 centimeter, all through the 1 centimeter. So anyway, this cuvette we will use. So you will use the cuvette to put the sample in, and the light source from here to here will go through this. Okay, if it go through this, then what will happen? See, it will absorb the light. Okay, it will absorb the light and it will transmit some of the light, right? If the concentration increases, then what will happen? It will absorb more, right? If the concentration is less, it will absorb less. Okay, but we will only detect the transmitted one. Absorbance one we cannot detect, right? So you'll detect the transmitted one. So with the increasing of the absorption, with the increasing of the concentration, the absorption also increases, and with the increasing of this law is called with the increasing of the concentration, the absorbance increases. It's called the Beer-Lambert law. Okay, you will learn it. So Beer-Lambert law, I think you Dr. Zhao already discussed it in your class. Anyway, so after transmit, and then it will be converted through the spectra, different spectra. So from this spectra, we can identify the amount, we can identify the element. Okay. So the first thing is that, as I said, first thing is that you have to know the lambda max. Let's see how to find out the lambda max. So in this video, I actually take this video from somewhere else. So in this video, it will show the 600 nanometer, but for our lab it will be 395.8 nanometer. We will use the 395.8, but in the video it will be 600 around nanometer. That is the same way, almost same way we use to find out the lambda max. না 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 চলো সমস্যা নেই চলতেছে এগুলো কেটে দিব আমি Okay, so you saw how to find out the lambda max. So you got the lambda max this. So once you got this, as I said, so this at this lambda max, it gives specific character. So at this lambda max, we will try to find out the we will use this lambda max to find out the concentration of the nickel. So to do that, first of all, as I said, we will give you nickel ammonium complex. Okay, so nickel and ammonium actually very tightly bond with each other, so it's very difficult to break this bond. So to break this bond, if we use the diluted acid to get the amount of the ammonium salt, okay, then what will happen? It will not give you the sharp peak. Okay, it will not give you a sharp peak like the acid base titration. Okay, but instead of that, what we do, we do the back titration. So we will add excess of acid. Okay, we will add excess of acid to neutralize the ammonia, as well as some acid will remain in the solution. Clear? So if some acid is remaining on the solution, from that amount we can find out what was the concentration of the ammonium. You know that is called the back titration. So once you know the amount of the nickel, and then you know the amount of the ammonium, okay, the rest of the things is what? Chlorine. It's easy. Okay, so you know the amount of the nickel with the help of the spectroscopic analysis. How to do that, I will let you know. Then ammonium is from the back titration, and chlorine is the, so if it is 40%, sorry 30%. If it is 40%, the rest is 100 minus 70, so it is 30% is the chlorine. We can find out anyway. So to do that, what do you need to do? First of all, you need to find out you need to dissolve the things in the, first you have to take the 5.311 gram of the salt, nickel ammonium salt, okay, nickel ammonium chloride. You have to take the 5.311 gram of the nickel ammonium chloride. So once you take it, then you are going to add 2 molar 75 ml of HCl. We know that that is excess. Whatever the excess, you will find out, okay, later on. So this is 2 ml of 75, 2 molar of 75 ml HCl. So, and you take it in the 100 ml volumetric flask. Okay, so in the 100 ml volumetric flask, you have taken 5.311 gram of the nickel ammonium salt, and then you are taking 2 molar 75 ml of the HCl. Everything is dissolved, and you will see that there will be a blue color. Then rest of the things you can fill up up to the mark with by adding the 25 ml of the water, deionized water. So you have, this is called we call it the unknown solution. Okay, you don't know anything, only the gram of the nickel ammonium salt. So, and by this time we already know how to find out the lambda max. We got the lambda max. Okay. Now what you need to do? You will take 1, 2, 3, 4, 5, 6 of the test tube. We provide you the 6 of the test tube. So you will give you 6 test tube, then test tube, and there will be a nickel chloride solution. This is the standard solution we will give you. Okay. So this is a nickel chloride solution of 0.5 molar. Okay. So from here, okay, we will take, you have to make standard carb. That means, so we will make a solution of 0.1 molar, 0.2 molar, 0.3, 0.4, 0.5. It is actually same as this one, and this is unknown. Okay. So how to make it? You will take 1 ml of this and 4 ml of water, 1 ml, 2 ml of this and 3 ml of water, 3 ml of this, 2 ml of water, 4 ml of this, 1 ml of water. The things is the 5 ml, and this one is the unknown, 5 ml of this one. Clear? So what is the concentration of this? This one will be 0.1, 0.2, 0.3, 0.5, 0.4, 0.5, and this is the unknown, you don't know. So take a cuvette. Cuvette is look like this. I am not drawing the whole thing. So cuvette is look like this, and 2/3 of the things, 2/3 of the cuvette, first you will clean it with the water few times, and then as you saw that first you have to do the blank. So you put this one as a blank first. So after the blank, then you are going to wash it with the water and put this one first a little bit, wash it. This is called rinse it, and after rinse, then you again put it. Okay, after putting, then find out the absorbance. So when you are going to find out the absorbance, at that time you have to put the lambda max. So in the computer you have to put this lambda max 395.8. whatever the lambda max you will get, this lambda max you will put, then run the sample, and you will see a point. Okay, that point, suppose the absorbance is 0.25. okay, I gave you the data 0.25. so the same way you are going to do for the 2, 3, 4 and 5. okay, and for those you are getting the data of absorbance at 0.5, 0.75, 1.00 and 1.25. this is 1.25. okay, and then the same way you are going to put the unknown. Okay, unknown, and you got 0.575. okay, by using all this data 1, 2, 3, 4 and 5, you are going to plot an absorbance versus concentration plot. okay, you are going to plot an absorbance versus concentration plot. So from here, then unknown, put the unknown somewhere over here. okay, and you will get an y equal to mx plus c. Okay, so put this value and find out the, say, absorbance, find out the concentration X. Y, it will be this one, and X will be this one. So find out the X. This is good. So you find out the X, and that X is actually the concentration of the unknown, right? So you know the concentration of unknown. Okay, so it is, suppose whatever it is, if I call it like A or C, the concentration of the unknown is C. If the concentration of unknown we know, you have to find out the number of moles. Of unknown. Okay, so this is the concentration. So what is the number of moles here? You can find out. Okay, the concentration means divided by, it's in 1000 ml, and a number of moles of unknown, it's in the 100 ml. Okay, so it should be what, you know that. Okay, then you also find out, I am showing you actually, anyway, I am showing you number of moles in unknown is the concentration multiplied with the volume in liter. Okay, then to cut off.